Good morning, my YouTube viewers. Crystal here. I'm here this morning because I want to give you a code review. What I did was I did the Analytics Vidhya course on loan predictions, and I wasn't going to give you a code review on it because it wasn't my own work. It was just work that I did on the course. But I had so many problems doing the coding and doing the work and getting it to work that I decided that I wanted to go ahead and do a code review anyway, just to show you the problems I had and what I had to do to get it to work. So this is the loan prediction course from Analytics Vidhya, and I'm doing this on Google Colab. The first thing that you had to do is you had to import the libraries, which we did. The second thing we did was we imported the training data set, which I did. And you can see that all of the columns in the training data set. Uploaded the testing data set. The testing data set has all of the same columns except for the loan status. And then what we did was we made copies of the training data set and testing data set. And then another thing we did was we checked to see how many columns we had in the training data set and how many columns we had in the testing data set. And you can see that the only column missing in the testing data set is loan status. So I wanted to get some information on the training data set, and then I wanted to get some information on the testing data set. I wanted to see the shape of the training data set and the testing data set. I wanted to see what values were in the loan status of the training data set. And then I wanted to see the percentages of the loan status of the training data set. And we made some graphs to see the loan status, graphical analysis. And then we made some more graphs. You can see right here that just tell you a little bit about the type of people that get loans and the type of loans that get approved. So we made some more graphs, and you can see the code right here. And these are the graphs that it made, and it just gives you information about the loans that get approved. So we plotted another graph about the applicant income, and as you can see, it gives you an idea of the income of the applicants, but there are a few outliers, and then you get a box graph for that as well. So this is your code if you wanted to copy the code. So we did another box graph, and we compared the applicant income and education to see who gets loans. And we plotted another graph as well, like co-applicant income. So that means that if you apply for a loan and someone applies for the loan with you, to check out the person's income who applied with you. Plotted another graph on the loan amount and a box graph to go with that. Plotted a bivariate graph with gender with regard to the loan status. And then we've got some more text. I know it's really hard. And basically, this bivariate, I think what happened was I couldn't get the bivariate graphs to work. And because I couldn't get the graphs to work, what I had to do is I had to do a search on Google. And on the Kaggle website, someone on the Kaggle website had posted the code on the Kaggle website. And so I had copied and pasted the code from the Kaggle website onto this selection right here just to get the graphs and everything to work, because it didn't work when I tried to type it in from Analytics Vidhaya, and basically what they had done is they had disabled the copy and paste function, so you couldn't copy and paste. You had to type it all in by hand, which meant that it was very susceptible to error because you could make a mistake when you're typing, and then you have to troubleshoot the mistake. So here's the bivariate graphs that came out from that code that I copied and pasted. So now we check the distribution of data, do some more graphs, give you some more information about the type of people that get loans approved. And then so we did a group by with the loan status and the application of income. So we did some more graphs, more applicant incomes, and then at this point we put them in bins of low, average, high, very high, and we plotted the graph on that. Plotted a graph on the co-applicant incomes. So what we did was we plotted a graph where we combined the applicant incomes and the co-applicant incomes. And now what we do is we have a heat map, and that'll give you some more information about the type of people that get loans approved. So the loan amount and the co-applicant income, it is a really big difference. The loan amount and the co-applicant income makes a big difference on that. I wanted to see if there were any null values, and yes, the true says that yes, there are any null values, and I wanted to see what columns the null values were in, so I tested to see what columns the null values were in. I did that on both train and test files, and then what I did was I found the columns that had null values, and I filled them. So I filled them with the mode, and then I think on one of them I filled them with the mean, although I can't find it at the moment, but I did fill them with the mode. So we did DF train loan amounts value counts. So we filled some more. So we did fill one of them, the loan amount, with the median. So what we did was, again, we went back and we checked DF train and DF test for any null values, and there were no null values after I replaced them. And this is the code for that, the code for mode and the code for median. So we wanted to make another graph, and this was a logarithmic graph because it sort of gave a better picture if it was logarithmic. And we dropped the loan ID column and the train file and the test file. We assigned the variables for X and Y, and then we did our get dummies, and then you have to do the get dummies as a way to prepare the file to be trained on. So we split our data into X train, XCV, Y train, YCV in the test train split. We did the logistic regression model. We did some more predictions. We did our accuracy score of 78%. And so pred test model is predict. And then I wanted to see what was in pred test, and it was all yeses and nos. So we loaded our sample file, and this is the loan status. And here's your file, your loan status. And then so you can see over here on the left side of the screen, you can see all of the submission files that I put together. And this file that I created was called Submission LP CSV. So what we did was we did a cross-validation on logistic regression, and this is the code for cross-validation. And I wanted to see what was in YVL because I had some problems with that. And it was supposed to be ones and zeros, but it wasn't. It was yeses and nos. And I wanted to see what was in PRED. So I put that in there. So I had to replace, in order to get the upcoming code to work, I had to replace yes and no with 0 and 1 and 0. So you can see that I replaced those values. And so we charted a graph. And then after I charted the graph, I needed ones and zeros to chart the graph. After I charted the graph, I went and replaced the zeros and ones with nos and yeses. So it went back to yes and nos. So we created another submission file. You can see the submission file that we created. And then we created a CSV file called submissionkf.csv. And then so the next thing we do is we plotted another graph on the applicant income and the co-applicant income. And then the next thing we did was we did this graph we plotted a logarithmic graph because it was a little bit closer to the center if it was logarithmic. So then we did another graph on EMI and loan amounts. And we plotted a graph on balance income and total income and EMI. So we dropped the following columns: applicant income, co-applicant income, loan amount test, and access equals 1. So you can see the new DF train, which is mostly ones and zeros. And so what they have done is they've made as many things as they can ones and zeros so they can use logistic regression. So now what we're going to do is we're going to do the decision tree, and here's the cross-validation for decision tree. Decision tree is also a model that uses ones and zeros, binary logic. So I wanted to see what was in PRED test, and so we've got lots of yeses and nos. And I created a submission file. And here's the submission file that I created. And we created submission DT, which stands for decision tree. The next thing we wanted to do was random forest. And so there's your code for random forest, cross-validation code. And after we did the random forest, we did some more work on the random forest. And there's your code for that. And we did the cross-validation code for random forest classifier. So I wanted to see what was in PRED test, and it was an array of yeses and nos. And so we created the submission file, and you can see the submission file that we created. And here's the CSV file we created called submission RFC. That's for random forest classifier. And you notice here, whenever you create these files, at the end of it, you have to say index equals false, because if you don't say index equals false, then the index will be included in the submission and it will fail. So the next thing we wanted to do was we wanted to check the importance of each column and a horizontal bar chart, so you can see that the credit history was the most important. And the next thing that we're doing is we're going to do XGBoost. But what happened with XGBoost is I couldn't get XGBoost to work with the code that was included in the Analytics Vidya course. I tried everything I could. I looked on the internet. I looked on GitHub. GitHub had some code you could use. I put the GitHub code in and it didn't crash, but it didn't work either. And then I found Kaggle. I tried to put in some code from Kaggle and it didn't crash and it didn't work either. And finally, I found some code from Jason Brownlee and I used code from Jason Brownlee and it worked. But it says here accuracy of 78.82%. But whenever I created the file and created the CSV file, which you can see it's right here, XGB, I only got 35% on the leaderboard. So I was looking on the internet, and the internet actually says that XGBoost doesn't really work with this K-fold. And so their XGBoost has their own code that they use to classify it. But since I had been working on it for a whole day, got up in the middle of the night, and I think I even tried to use the code to classify it and I couldn't get it to work, I thought, well, I'll just stick with this code that Jason Brownlee has provided, but it has a very low accuracy rate. It's only like a 35% accuracy rate because it's a very simple code. So that's it really. So XGBoost doesn't really work with the code that we were given from Analytics Vidya. And I had to use other code, and I had to spend a lot of time troubleshooting this code just to get it to work. For one thing, one of the things that they did is one of the bits of code that they used, the file was a yes and no, and it needed a 1 and 0. So I had to convert the yes and no for 1 and 0 to 1 and 0. That was one of the things that I had to do. Another thing that I had to do was I couldn't get the graphs to work in the code that they provided, so I had to find other code that I got off the Kaggle website. And the third most important thing is we couldn't get XGBoost to work. And so I had to use some code from Jason Brownlee just to get it to work. So that concludes it for my code review of the loan prediction of Analytics Vidya. I hope that you got something out of it. And I tried to work slow enough to where you could see the code if you wanted to copy and paste the code, or you can't copy and paste it because it's a video. But if you felt really ambitious and you wanted to type the code in, then you can certainly see the code to type it in. So that concludes it for my video. So if you like my video, please like, subscribe, and share. If you like the work I do and you want to make a donation, I have my email address down below if you want to make a donation to my PayPal account, which it will be very gratefully received. And let me know what you think about this video. I made sure that I cited my sources, that I said where I got my sources from, because I don't want anyone to say that I'm plagiarizing. And thank you so much for watching this video, and I will see you next time.